Alright, this is a quick video for Exploration 1.5. You can see the title, Be Careful with Your Calculator. And we're just talking about things that can go wrong when you're using your calculator to do computations. Maybe even figure out what you did wrong, correct things that went wrong, etc. I'm going to do some of the problems, and you guys are going to do some of the other ones and turn in your completed exploration. Alright, so here's a question. You bought a car for $8,450. You got to pay sales tax on that, which is so fun. And we compute how much that is going to be, and our calculator says $50,700, which is clearly not correct. So what went wrong? Now, you could make some guesses and try to verify it. That would be the way to certainly know what went wrong, but you could just make some guesses and go with that too. Well, what if, how do you compute 6% of something? You may remember that what you do is multiply by 6% as a decimal. So that is, you do our sales amount times 0.06. Well, how did we get this? Probably by forgetting that whole decimal version of the percent and just typing in 6. So, what precisely was the error? Multiplied by 6, not 0.06, which would have been a lot better. So the thing is, okay, what's the real amount then? Of course, you could get your calculator out and do it correctly and see what you get. But multiplying by 6 and multiplying by 0.06, well, this just comes from moving the decimal point. All right, so to go from 6 to 0.06, you're moving the decimal point over 2 places, and when it comes to multiplication then, to fix that, you can just move the decimal point of your original answer over 2 places. So, okay, that's way too huge. We're going to expect it to be smaller, so we could actually take that decimal point, 50,700, there's our decimal point, and just move it over 2 spots. So our correct amount would be just 507 decimal point, just $507. All right, and if you were to check the calculation, yep, that's exactly what you would get. But you don't have to go through and redo the whole calculation. Just realize that, oh, I was off by a factor of 100. That's what 2 decimal places represents. And so you can adjust your answer by a factor of 100 and get 507. All right. The next problem is for you to do, but it's sort of similar in nature, and people are faced with computing tips in restaurants all the time. All right, so suppose you had, this is a relatively fancy meal here, $142 for 5 people. You try to compute 18% as a tip, and you come up with this number. Now, hopefully you look at that number and say, that's way too small of a tip for a bill this big. All right, so what probably went wrong, and how could you just fix it up without having to redo the whole calculation? All right, I'm going to let you guys figure that one out. All right, so mistakes with decimal points. That was the theme of those 2 problems. All right, in the medical field, dosing calculations are a big deal and important to get correct. Here's an example, not of a dosing calculation, but of a different sort of calculation that could go wrong. So we have this table of information about a patient, and they are monitoring how much food, liquid, whatever they are intaking in terms of volume. And so we have these different things that are being taken in by the patient and how many times or how many servings they're getting for each one. And a doctor does a computation and comes up with this number, and that should be in milliliters. All right. Now, almost 5,000 milliliters. That's 5 liters, straight up liters instead of milliliters. If you think about how big a 2 liter of pop is, and we're talking about 5 liters of fluid, this patient is not intaking that much. So what went wrong? This one's a little harder to diagnose, but we can correct it as well. And maybe the way to figure out what went wrong is to just do it correctly. All right, so coffee, 200 milliliters for every serving, and that happened twice a day. So in terms of the coffee, this patient took in 200 times 2. That is 400 milliliters. One serving of Boost, so that's 150. Mylanta, 2 doses of 30 milliliters. So that's a total of 2 times 30 is 60. 100 milliliter ice cream. And 4 of these medications, so 4 times 15 milliliters is 60. So I'm just going to call that meds. 60 milliliters. So what's the total then? Yeah, you can get out your calculator, you can do it in your head, whatever. I don't have my calculator sitting here. 550, 650. I believe we get 770 milliliters, which is way off from what this doctor computed. So what did he do? Well, you can see what we did was we multiplied across in the rows. We did 2 of those and 1 of those and 2 of those, etc., etc. 4950 could come from doing that incorrectly. Ultimately, we know we need to multiply across the rows and then we need to add. But what if you did that in the wrong order? If you just added these all up, right? So what was the error? Added and then multiplied. And watch how this comes together. If we add these together, 200, 350, 380, 480, 495. These add up to 495 milliliters. What about these guys? Well, if you add up those numbers, you get 10 servings. But that just overcounts everything. That's like saying you got 10 servings of all of these. All right? Multiply, and you get 4,950 milliliters. All right, make sure you note, though, that all of this was wrong. That is not the correct answer. Now, there's no simple way to fix that other than to go through and actually do the calculation correctly, which is what we did to get 770. But adding and multiplying, you can't just do those in whatever order you want. The good old order of operations is important here. And obviously the answers are way different as well. Okay. Top of the next page, there's one for you to do. I'll just let you read it and do it. Part C. So here we have supplies for EMTs. All right, we're getting a discount. So one set of supplies contains all of these things, and this is the price per item. And notice we have multiples of these items as well. And we're getting a discount of $3 off of every set. All right, and we bought 15 sets total, and this was our bill. Now, there's an error there. And maybe we should do it correctly to try and figure out what that error was. So if we do it right, well, we have 15 sets, but we need to know what one whole set costs, and then we can figure out our bill. All right. So 3 boxes of bandages, $2 a box. That's $6. 2 boxes of thermometers at $1.50 each, so that's $3 for those. 1 blood pressure cuff, and there's only one of those, so $12.50. And 4 boxes of syringes, 75 cents a piece. That works out to $3. And so we have a total per set of $24.50. All right. But now we get a discount. So here comes our discount. So that means we should be paying $21.50 for each set. And so times 15 sets, Does that work out to this? Did they bill us the right amount? Here's a real quick computation on my computer. 21.5 times 15. And I get 322.50, which is quite different from 364.50. So what probably happened here? Why is it so much higher? Well, notice we're getting a discount of $3 per set, not just $3 on the whole order. So if we did $24.50 times 15, that's what the normal price would be for 15 sets. And if you do that computation and just take $3 off, you get this number. So what was the error? Discount taken only on the whole order, not each set. So that's like the $3 only got subtracted one time, when really $3 needs to be subtracted 15 times for every single set. So if we just lower that price by $3 and then multiply by 15, we get what the real price should be. And this is really another example of doing multiplication and addition or subtraction out of order. If you take the original price and multiply first, then subtract, you're not taking $3 off each set, you're only taking $3 off the whole order. But if you subtract first and then multiply, you get a very different result that corresponds to how this is actually described. You will see as we do some explorations the occasional question about quantitative ethics, which is not, you don't really expect ethics questions to show up in a math course. But there are plenty of places where the abuse or misuse of numbers can raise ethical questions, and this is one that's right here, and that's just for you to answer, and I'll leave it as that. All right, one more page. I'm actually going to let you do this problem on your own. All right. If you look at the situation, $2,500 in a savings account that earns 2% interest. 3 years later, it's worth $16.5 billion. That'd be great, but it doesn't work that way, so something went wrong with that computation. I'm going to go through this one with you instead. All right, so a machine, when a business buys a big piece of equipment, there's a way for them to deal with that expense on their taxes that requires them to compute what that machine should be worth every single year. The details of that business setup are not something that we're going to explain. What we're going to look at here is that, well, I'm thinking we might have a typo in here, because I think those two numbers should match each other. I'm going to pause the video and check it out, and then we're going to come back. Okay. All right, we're back. Here's how we're going to fix this. 28,000, we're going to cross that out and write 11,200 instead. All right. Perhaps that will be fixed by the time I actually copy this and hand it out to you, but if it's not, fix that right there. So we have a piece of machinery that costs that much, and this is the formula that describes, for this particular machine, how the value of it goes down. So it's getting older, so it's worth less. And so you do a computation for t equals 3. So when the machine is 3 years old and supposedly it's only worth that much money, and that strikes you as just being way too low. It shouldn't be worth that little already if we've got to get 2 more years out of it. All right, so what's correct? Now, this is not a real complicated formula. We have a t right there, so all we got to do is plug in the age of the machine, and it will spit out how much the machine is worth. All right, now, there's something you got to pay attention to here when you're typing things into a calculator, especially if you can type this whole expression into a calculator. So, for example, if you type 11,200 times 0.6, and then you do to the power of 3 minus 1. If you type that in your calculator, all right, calculator just has the one line of input, doesn't have subscripts and that sort of thing. Order of operations says that exponents come before multiplication and before addition and subtraction. Written like this, a calculator or Excel, for example, would take this as raise 0.6 to the third power, then we'll multiply by 11,200, and subtraction comes last at the end. All right? But this t minus 1 is in the exponent. All right? There's no parentheses around it, but something up in the exponent like that is technically all grouped together, and that computation needs to happen first. So if you wanted to type this whole thing in and make sure the computation happened correctly, well, you need to do 3 minus 1 before that, and you would need some parentheses around there. The subtraction of 1 is the first thing that happens when you put a number in for t. It's not the last thing. So do the subtraction, raise 0.6 to that power, multiply by 11,200. And if you do that, the correct answer should be 4,032 instead. All right, so what was the error? Didn't subtract 1 from t before computing the exponent. Okay. And that's the end of the exploration. So there's some questions for you to do and fill out. You can fill in the summary here. What kind of errors did we see? We saw decimal point errors, and mostly that and order of operations errors, really, more than anything else. So it's not just like you didn't know how to use your calculator, but it's knowing the correct thing to compute and being able to do that correctly on your calculator. So this one was ultimately an order of operations error, but not because you necessarily were doing the wrong things, but because the way it was typed into the calculator, the wrong thing was happening. All right. All right, that's it.